Hi, welcome to my channel Too Irrational. I am Pranay Sharma and in this video we'll learn about permutation and combination. Using permutation and combination, we find the total ways of selection and arrangement of objects. To understand permutation and combination, we need a little prior knowledge about factorials and fundamental principles of counting. I have made a video on it and the link is in the description. Please watch that first and come back here. I'll wait. So I'm assuming that everyone is back and caught up with factorials. We'll move forward with combination. Combination is used to calculate total ways of selecting R objects from n unique objects, assuming R is less than or equal to n. We write combination as NCR, that is equal to n factorial by R factorial n minus R factorial. Let's take an example. Out of 4 colors, let's find the total number of ways of selecting any 3 colors. That we can do in these 4 ways. Note that here we are only selecting groups. The order of colors in the group does not matter. Let's use the formula and find if we get the same results. We are selecting 3 objects out of 4 objects. So we'll say 4C3 will be 4 factorial, 3 factorial, 4 minus 3 factorial. That we can solve and get our answer as 4. Now let's talk about permutations. Permutation is used to calculate total ways of selecting and arranging R objects from n unique objects. Assuming again R is less than or equal to n. We write permutation as NPR is equal to n factorial by n minus R factorial. Now let's take an example. Out of 4 colors, let's find the total number of ways of selecting any 3 colors and arrange them. Here we can see it takes 24 different ways. What about using formula? We'll say we are going to select and arrange 3 colors out of 4. So the formula becomes 4p3, that will be 4 factorial upon 4 minus 3 factorial. That gives us 4 factorial ways or 24 ways of arranging them. Using these basic concepts and formulas, let's try to solve some examples. For the first example, find the number of 4 different letter words with or without meaning that can be formed from the letters of the word number. Now here, number has 6 letters and we need to make 4 letter words. Now it does not matter whether those 4 letter words have meaning or not. So all we have to do is arrange these 6 letters into 4 letter words. So we need to select and then arrange as well. So therefore we'll use permutations. That would be nothing but 6p4, that is 6 factorial by 2 factorial, which gives us 360. For our second example, we take how many different boat parties of 8 consisting of 5 boys and 3 girls can be made from 25 boys and 10 girls. Now here clearly we are going to select from 25 boys 5 boys and from 10 girls we are going to select 3 girls for each of these boat parties. Now arrangement of these students does not really matter. So therefore we are just going to do selection, that would be our combination. So we get 25C5 and 10C3. Now because they both are supposed to be happening together, that is why we'll multiply these two. Using formula of combinations, we can say we'll get 25 factorial by 5 factorial 20 factorial into 10 factorial by 3 factorial 7 factorial. We'll reduce the factorials and solve them to find that we have a very large number here. We have 6375600. So we have these many ways to select 5 boys and 3 girls for that boat party of 8 from 25 boys and 10 girls. Now we understand the basics of permutation and combination and how to use them. Let's find mathematical relations of permutation and combination that might be useful for us in the future. As we said, permutation is selection and arrangement and combination is selection only. We can say permutation, that is our NPR, is equals to NCR times the ways of arranging our objects, that is R factorial. Let's turn to second relation. The number of mutually distinguishable permutations of n things taken all at a time, of which P are alike of one kind and Q are alike of second kind, is n factorial by P factorial Q factorial. I know it's difficult to understand. Let's take an example. Let's find total ways of arranging letters in mathematics. Now here you can see in total we have 11 letters, but M, A and T are repeated 2 times each. Now whenever we have such repetition, the thing is that if we replace them, I replace one M with another, it still makes the same permutation. So we cannot count it 2 times. We'll have to divide those number of values where I can rearrange them. So the total number of ways will be 11 factorial divided by 2 factorial for repetition of M, 2 factorial for repetition of A and 2 factorial for T. So whenever we have repetition, we'll just divide by the number of times we see those repetitions. For combination, we have a lot of relations. We can call them as properties of combination. Let's go through them quickly. We'll say NCR is equals to NCn minus R. This is the most simple and the most used relation. The second is NCR plus NCR minus 1 is equals to n plus 1 CR. Third one, NCR also gives us n by R into n minus 1 CR minus 1. For the fourth, if n is even number, then NCR is greater when R is equals to n by 2. That is, the middlemost value will be the highest. And if n is odd, then NCR is greatest at n minus 1 by 2 and n plus 1 by 2. Those are the 2 middle values there. Lastly, if we add up all combination with different R values ranging from 0 to n, then the value we get is 2 to the power of n. This implies the number of ways we can select any number of objects, that also includes not selecting any object, from n unique objects will be 2 raised to n. In the next video, we will solve some examples using all of these relations and learn how we actually use our permutation combination for solving different types of questions. If you like this video, please like, share and subscribe, and I will see you in the next one.